Alright, so this is a question you can expect to see if you're taking grade 11 university preparation for chemistry. So it says rubidium has two isotopes. 85 rubidium has atomic mass of 84.9 AMU and 87 rubidium atomic mass of 86.91 AMU. So it wants us to determine the percent abundance of each isotope for rubidium. And we know that both of these, first thing we need to do is we need to get the average atomic mass from our periodic table. So if we look at our periodic table, we can determine that rubidium's average atomic mass is about 85.47. That's just from my periodic table. So now that we have the average atomic mass, we know that this is the value of all the isotopes of rubidium together. This is 100%, basically. So if we want to know what percent both of these fall into here, we can use this equation, which is of average atomic mass goes the first atomic mass of the first isotope and the percent abundance of the first isotope plus, these are both multiplied together, plus mass of the second isotope and percent abundance of the second isotope. So what we're trying to solve for is trying to solve for P1, P2. So I already know average atomic mass. So we can just plug in this average atomic mass for now. So 85.47 mu. This is the average atomic mass equals the atomic mass of the first isotope. Let's start with 85 rubidium with an atomic mass of 84.9 times P1 plus the atomic mass of the second isotope, which is 87 rubidium at 86.91 AMU. Times percent of the second isotope. And now what we can do is, well, just look at it like this. So 85 rubidium, 87 rubidium, and percent. So we know the mass is 84.9 for that one, 86.91. Now that we're trying to find the percent, a way we can do this is we can actually classify them as x and x minus 1 minus x, and what that means is basically both of these have to add to 100%, right? So we can classify this as x, and let's say this is like 40% of the thing, of the isotope, right? And let's say this is 60%. Now, obviously, we can't use x here as well because that would just make 2x, and then the equation would be wrong. So what we're going to have to do is classify this as 1 minus minus x, because if x is 0.40, then this would equal 0.60. In other words, 60%. So that's the type of equation we want to do. And it doesn't matter which one you put as x and 1 minus x. I could bring this over here and I could bring this over here, and it still give us the same answer when we put it in for P1 and P2. So now that we have this, we can imagine the P1 as actually be 4.9 x that's being multiplied. Let's just imagine this as x. Imagine this as 1 minus x. So now that we have this, what we can essentially do is just start plotting out this algebraic equation plus 86.91, 1 minus x, which would then turn into 7 equals 84.9x plus 86.91 minus 86.91x. And now we just solve this, like we have a one variable equation. We can just solve for that variable by combining like terms and bringing stuff to the other side. So we can bring this to the other side because they're both numbers that can be combined. So now we will have 85.47 minus 86.91 equals 84.9x minus 86.91x. Now that we have this, we can just do the calculations. 84.47 minus 86.91, negative 1.44. 84.9 minus 86.91 gives us negative 2.01x. Now that we have this, divide both sides by negative 2.01. And we can just put this into our calculator. So on this side, this would give us roughly 0.7164. That's just the first 4 digits equals x. And what we can do with this now is, so now that we have this, this is our percentage for x. And remember what x was 85 rubidium. So now we know that essentially it is not 40%. It's roughly 71.6%. Just put 64%. And now what we can do is just input this into here because it has to add up to 100, right? So this is 1 minus x. So 1 minus 0.7164 equals the percent of the other isotope. And this is basically about 0.2835820. I really don't need to spill out all of the digits, but it's 3 times it by 100, 28.35%. So now we can put this here, 28.35%, and that's our answer for both the isotopes. Determine the percent abundance of each isotope for rubidium. We found out that 85 rubidium is 71.64% of rubidium, and 87 rubidium percent abundance is 28.35% approximately. So those are our final answers.